So here we're dividing these items among 3 children here. Now, if we look at just the erasers part, we have 3 identical erasers, and so we have to split them. It could be 2 here, 1 here, 0 here, so on and so forth. But if you look at the other cases too, they are actually the same as this case. And why is that? If you look at the 6 pencils, they say each one gets at least 1 pencil. So you have 1 pencil, 1 pencil, 1 pencil. So now we have already given each person 3. Now we're left with 3 pencils. So dividing these 3 pencils is no different than dividing these 3 erasers that are identical among 3 children. And next, if we look at the case of the 15 balloons, each one gets at least 4. So if you give them 4, 4, and 4, 12, now we're left with 3 balloons. And so it's about how can I divide those 3 balloons, which is no different than the eraser case or the pencil. So this question really is about how do I divide 3 items among 3 children. And of course, if you don't know about partitions, you could do it brute force. You could say 0, 0, 3, 0, 3, 0, 3, 0, 0, 1, 1, 1, 2, 1, 0, and then this one you'll see it will be 6 because they're all distinct. And that's it. So 3, 6, 10. So there are 10 ways I can divide those either 3 erasers or the remaining 3 pencils or the 3 balloons. And so each one can be distributed in 10 ways. So the total number of ways would be 10 times 10 times 10, because each of these distributions will then be paired. We'll have similar 10 for the case of pencils and 10 for balloons. And so each of those connections or the branches will give you one particular distribution. And that's why we're multiplying it. So the answer is 1,000. Now, another way to think about this, which has to do with partitions, and I would urge you to go ahead and learn about this concept, because there was another question in a recent CAT which used that concept. So here what we're doing is, if we look at the case of the eraser, what we do is we put an S here. This letter S is kind of the spacing between. And and you can think of these as letters. E represents the eraser and S is the spacing. Now, if you look at this particular organization, that means each person gets 1, 1, and 1, because the S is the spacing, meaning that's the division. Now, we could rewrite this as E, E, S, S, E. In this case, the first child gets 2, next one gets 0, and then the third one gets 1. And so you can organize these letters. You could have it something like this, in which case you have 3 to the first child, 0 to the next, and then 0. So this question really is about how many different ways I can arrange these 5 letters. And you might already know this. When you have repetition of letters, this would be 5 factorial over 3 factorial, 2 factorial, which you will see does come out to 10. And that's another way to do this question. In fact, if these numbers were larger, then listing them all out would be time consuming. In that case, you would have to kind of understand how to do this. So this comes under partitions and is helpful, it seems, because same question has been asked or similar in recent exams. So I would say make sure you kind of understand that concept, because it's difficult to kind of come up with a new method in the exam. There's already very little time, so much pressure, so you don't really have that luxury. But yeah, the answer here is 1,000.